In our last lesson, we explored the unique challenges of complex building cavity return systems, such as we see in a lot of basement-style houses. Now, in part 2, we'll introduce you to recommended advanced processes your technical team will follow when using AeroSeal to tackle them. This will help you have the most productive conversations with your clients, as well as with your AeroSeal technicians. The AeroSeal Technical Training Department is your crew's best resource for more in-depth help. Dealers who routinely successfully tackle building cavity returns don't wire the two sides together. They usually split the project so that they do two separate AeroSeal events, usually the supply side first and then the return side, two separate sets of tests, seals, and certificates. There are 4 advantages of doing this. First, there's often no choice. A big challenge with building cavity returns is that they can be so leaky that a single AeroSeal machine simply can't build up enough pressure to even start the seal. Trying to test both sides at once, trying to also build up pressure on the supply side at the same time as the return, just makes it that much harder. So a good best practice when there are extensive and complex building cavity returns is to simply plan right out of the gate to tackle the two sides separately. Second, there are some work efficiency benefits. Once the starting leakage levels for both sides have been separately measured and saved in the computer, the team starts pre-sealing the return side by hand while the machine is sealing the supply side. Sequence-wise, it usually makes sense to first hook up the lay flat to measure the return side and capture and save its pre-seal test number. Then switch the lay flat over to the supply side and test and seal it. Then, once the supply side is completed, reconnect the lay flat back to the return side, retrieve the return side pre-seal test, and continue for the longer remainder of the job. While the return is being AeroSealed, the crew will remove the supply side register blocking, hand seal the boot leakage if needed, and reinstall registers or diffusers. They remove the supply side isolation blocking at the equipment, patch the supply plenum, and hand seal any equipment leakage in the vicinity. Also, getting the supply side over with early with a successful and impressive reduction seal certificate in your hand puts your lead in a better position if it turns out to be necessary to have an awkward conversation with the client because it turns out their return side has massive hidden leaks. Mrs. Jones, I have some good news and some not so good news. Nice to have that certificate for the supply when you have that conversation. Third, sealing the supply and return sides separately provides 2 separate seal certificates showing each side's starting leakage level, the final leakage level, and the percentage reduction. As we'll see in our next lesson, this is very helpful to both control homeowner expectations during the initial sales conversation and also to ensure they are still happy with the job if it turns out the return side can't be completely sealed as part of the quoted scope of work. Fourth, keeping the 2 sides separate produces the cleanest and most understandable seal certificates. The supply side will routinely be an uneventful, no drama, and fairly quick seal, and we get the classic nice, smooth, steady downward curve with no hiccups, and hopefully an over 90% reduction. This was my house's sheet metal duct supply side that only took 24 minutes. On the other hand, the return side certificates graph can sometimes be kind of messy looking. There might be a steep drop in the first minute right at the beginning because it captures the pre-sealing work that was done by hand. If doing the divide and conquer technique, which I'll explain in a minute, it might drop a bunch more and then bounce back up only to come back down again, perhaps multiple times. And finally, it might flatline at a relatively high level. This can all be explained, but it's nice to keep all the explanations to one of the 2 certificates. Next, before blocking and injecting AeroSeal into the returns, the crew will do a very thorough visual inspection. Now, while a helper can be very useful in removing the return grills, the most trained and experienced lead technician must be the one who very intentionally looks into all the return grill inlet openings and the ends of all accessible pan joist bays for any missing headers. If things are looking suspicious, some dealers will invest the time now to sneak a duct inspection camera into the cavities to really figure out what's going on inside. The call then is made as to whether it will be necessary to return to this opening after the pre-seal test is captured in order to do any hand sealing and damming before injecting sealant, or, as is usually the case, whether we can count on AeroSeal to seal what's accessible through this grill opening. The helper can then proceed to block the opening with foam blocks or gasketed plywood plates or similar. Next, the initial return side pre-seal leakage measurement is conducted and the results are saved. We are capturing all the return side leakage that exists in its as-found condition before any hand sealing is done. There are two reasons for this. One, we want to document all the return leakage before doing any sealing, whether AeroSeal or by hand. This ensures that we get full credit for the final results. This really helps both the homeowner and ourselves feel good about the work done. For example, let's say the actual total return side leakage was 1,000 CFM. And after doing the entire project, the seal flatlines at 250 CFM. And that's where we stop. So we got rid of a whopping 750 CFM, a very respectable 75% reduction. However, if the crew never nailed down the real total leakage and just started doing the pre-sealing by hand, they could hypothetically take the first pre-seal test when the leakage is already down to 500 CFMs. Then they inject sealant and have to stop at 250 CFM. So it looks like your team only got rid of 250 CFM for a not quite as impressive 50% reduction in the initial leakage. Reason number two to do a return side pre-seal test before hand sealing anything is it gives the crew an idea of the challenge they're facing. Here's a useful guideline. If the return side pre-seal test shows more than about 1,000 CFMs of leakage at 25 pascals, or 190 square inches of combined holes, the crew is for sure going to have to do either pre-sealing or the divide and conquer process to be able to get the machine to start sealing. On the other hand, if our pre-seal test shows a manageable level of return side leakage, like under 700 CFM, then we know they won't have to spend a lot of time pre-sealing leaks that the machine will be able to seal. Before injecting sealant, especially if the initial pre-seal test number is high, which could indicate missing headers or end caps, many dealers will then use theatrical fog to try to find abnormally large leaks and also any missed return grill openings that weren't blocked. In addition to roaming the entire house, basement and crawl space looking for escaping theatrical fog, if possible, it's smart to poke a head up into the attic, just in case a wide open wall cavity is letting it escape up there. Remember, it's a lot better to find big leaks and any missing return inlet blocks with sweet-smelling theatrical fog that will dissipate than with sticky sealant. Now it's time to really get to work. Most often, a crew will now roll up their sleeves and do a lot of hand pre-sealing of the big accessible return leaks. Mastic, foil grip tape, even expanding canned foam. If there are any accessible wide open wall or floor cavities or missing pan joist end caps, they also install solid blocking like thermopan cardboard, ductboard, sheet metal, or lumber where needed. In cases where big leakage issues just inside the wall or floor level return grill openings were identified when prepping for the pre-seal leakage test, the foam or gasketed plywood blocking there is now temporarily removed. Hand pre-sealing or permanent damming can now be done there, and the isolation blocking is reinstalled. Remember, we didn't seal these big leaks earlier because we hadn't yet captured the pre-seal test numbers. This brings up one of the biggest variables to watch out for when quoting a basement house job that uses hollow wall cavities in the living area connected to pan joist cavities in the basement. If the entire basement ceiling is finished with solid drywall and the metal return trunks and pan joists and end caps simply aren't accessible, it's a lot less likely that the crew will be able to do a successful return side seal. See, if the basement's totally unfinished, it's pretty easy to find and seal any big leaks around the panning to trunk connections, the plumbing pipes, or missing end caps. Sometimes holes need to be cut into the sheet metal to seal from the inside, but they're easily patched. But if the ceiling is mostly finished, all these leaks are inaccessible unless drywall cutting is done. The same applies to a lot of older houses that have undergone multiple renovations and additions. A drywall sealing under all the return trunks also makes the divide and conquer technique much more difficult. In addition, with finished basements, larger than normal amounts of sealant overspray will likely need to be handled. You might want to keep all this in mind as you figure out your pricing, as you give the customer options, and as you prepare the client for whether extra work might be required to get a significant return side reduction, and as you prepare them for what the repair day will actually look like. Let's now take a review and discussion break, and when we get back, we'll actually start injecting Aeroseal sealant. So, after the initial steps of doing the careful inspections, measuring the pre-seal leakage, and doing as much pre-sealing by hand as seems right for that job, it's now time for the crew to attempt to seal using Aeroseal. They fire everything up, see what the leakage has dropped down to, and start injecting the sealant fog. By the way, it's important to not erase the earlier pre-seal test number. Do not repeat the pre-seal test. Retrieve the earlier saved test and then proceed to the sealing steps. If the machine is able to develop enough pressure to start sealing, all is good, and the crew lets it do its job. However, if there's still so much hidden leakage that the machine can't develop enough pressure to even start sealing, the process is paused. The technicians will now ideally implement a technique we call divide and conquer. They break the return side of the job down into more manageable pieces. Typically this means cutting again into the return trunk but further away from the injection point and inserting another isolating barrier. This takes the further parts of the return system temporarily out of the equation. They then seal just one section at a time, starting near the equipment. Once one section is successfully sealed, they open up the next section, add it to the seal, and keep going. 2 or 3 separate sections are typically done, and even more is technically possible. These steps show up on the seal report graph as waves. This approach is usually successful when the problem is simply lots of little leaks and there aren't any massive catastrophic holes. The divide and conquer technique can also really help the crew figure out where any hidden massive holes are up in the guts of the house. There is another shortcut that can work when the crew can't get enough pressure to start sealing, and that is to temporarily move the blue tube that picks up the duct pressure to closer to the machine, even into the lay-flat duct. Your Aeroseal technical trainer can give you guidance on this. I prefer to try the divide and conquer technique first myself, when it can be done. When injecting the sealant into building cavity returns, especially in basement-style houses, the crew uses creative ways to handle the inevitable large amounts of overspray in the basement, as well as leaking out of cracks in electrical outlets and can lights up in the living area. Lots of protective preparation covering furniture and electronics, multiple air scrubber fans, blue tape over the can lights. They suck the overspray directly out of ceiling spaces and mechanical rooms and vent it to outside. My favorite technique is to crack open windows everywhere and create negative pressure using fans and windows or even a blower door to ventilate the airborne sealant out of the house and not ever give it a chance to settle. In cold weather, electric space heaters will help keep the house from getting too cold. While sealing, they will inject sealant as long as the pressure in the returns is gradually building and the leakage level is at least gradually decreasing. A relatively slow improvement is often a sign that many of the leaks being sealed are bigger than the optimal under 5/8 of an inch width. But since there's no other way to get to these hidden or difficult to hand seal leaks, they patiently let the system do what it can. Often, the seal will continue and we'll get a very significant reduction in return leakage. I have seen a few systems that had over 1,000 CFMs on the return side get sealed all the way down to below 20 CFMs. More often though, we consider a building cavity return seal pretty successful if it reduces leakage by over 50%. Which means if it started at, say, 800 CFMs, they got it down to below 400 CFMs. So, why stop at, say, 400 CFMs? What is typically happening that causes the technicians to stop sealing is what we call flatlining. The graph shows the leakage level reducing, but at some point, the rate of descent slows right down or even stops. What this indicates is that the Aeroseal process is not able to seal any further. Basically, the remaining leakage is too big, well beyond our 5/8 of an inch guideline. It could be one really big hole, or a bunch of medium-sized holes. The sealant we're injecting is simply blowing through the remaining big holes. Now, here's a very important insight when this common situation happens. The good news is that even if there is still significant remaining leakage in the form of hidden big holes, the odds are that the process so far has managed to find and fix most of the worst building cavity leaks that are in the structure. Which are the worst, you may be wondering? The many small gaps and wiring holes that communicate up to the attic or sideways into the exterior walls. Basically, this is the return side duct leakage to outside. Here are some pictures I've taken of how well Aeroseal seals the critical leaks in the top plates that lead up into attics. By sealing this large quantity of small leaks, we stop the normal operating condition return suction from pulling in hot, humid, dirty air in the summer and cold, dry, dirty air in the winter. The fact that the most important leaks mostly get sealed, even if the return seal flatlines at a somewhat high leakage rate, should be part of your initial sales conversation with your customer. Now comes the point where a judgment call is needed. As a rule of thumb, if the crew followed this process and got over a 50% reduction, there's a good chance the remaining leakage is all inside the house, and it's likely hard to justify spending any more time and the client's money doing advanced searching and then cutting into drywall to fix the remaining holes. However, if the graph flatlines without getting a significant reduction, or if the crew couldn't even start the seal at all, a dedicated crew will stop injecting sealant and use duct inspection cameras, even thermal imaging cameras, to try to figure out where the remaining hidden holes are, like hidden missing blocking between the floors. If they can figure out where the pre-existing practically structural failure is, the crew chief then lets the client know what extra cutting and drywall patching work would be needed to make a big difference, quotes any extra work as a change order, and asks if the client wants to proceed. If it comes to this, your lead AeroSeal tech would need to be fully briefed on how to communicate the change order discussion and how to price it, and how to ensure a traceable agreement to proceed is documented in writing or by video before cutting into any drywall. In our next lesson, I'll share some sales and communication tactics that will make this whole somewhat complex repair strategy a viable business proposition. Keep your chin up. Building cavity returns are a challenge, but we can fix them. If not perfectly, at least enough to make a big difference and deliver good value. And remember, as long as we professionally and transparently communicate with our clients, we can ensure that their problems don't become our problems. And more important, we can turn their problem into an opportunity for all of us. I'll see you on the next lesson.